Hello, this is team number 21, IT Department batch 2013-2017. The title of our mini project is Encryption of Text and Image using AES. Our team consists of 5 members: Saisnya Mulpuru, Abhinava Voraganti, Vishnu Shravya, Haripriya and Bhavyashri. We are privileged to have the guidance from Dr. Padmalaya Naik, Professor, IT Department. Coming to our abstract. Today, almost all digital services like internet communication, medical and military systems, multimedia systems, banking account systems requires reliable security in storage and transmission of text and digital images. The main aim is to protect the system from the illegitimate users. The difficulties in ensuring individuals' privacy becomes increasingly challenging. Various methods have been investigated and developed to protect data and personal privacy. Encryption is probably the obvious one. We have an advanced encryption standard which is AES, accepted as a symmetric cryptography standard for transferring block of data securely. Image or text data is given as input to AES encryption to obtain the encrypted data, and encrypted data is the input to the AES decryption to get back the original image or text. Such encryption technique helps us to avoid intrusion attacks as is more secure than EEE. AES is faster in both hardware and software and has variable key size so that security can be increased when needed. The main aim of this project is to protect the system from hackers. The application provides encryption of text and image by generating a random key. Due to increased use of computers nowadays, security of digital information is most important thing. So, when we look into the intruder is an unwanted person who reads and changes the information while transmission occurs. This activity of intruder is called intrusion attack. To avoid such attack may be encrypted to some formats that is unreadable by an authorized person. AES is mainly advanced version of data encryption standard. And AES completely depends upon the key strength. That is nothing but as the key size increases, the number of rounds increases. Then the security is highly achievable. The main aim of this project is the complexity of the algorithm must be increases and in, and the number of rounds must be increased so that unauthorized person cannot access the key or the data which is being sent to the receiver from the sender side. So when we look into the key length, if we have 128-bit key length, then the number of rounds in the algorithm is 10. When we have 192-bit key length, then the number of rounds is 12. And if we have 256-bit key length, the number of rounds is 14. Now let us look into the execution of our project. I run my file. We used NetBeans IDE 8.1, which is completely based on Java coding. As I already told you before, our aim of the project is to hide the text and image. So now I click on text encryption. There's a text field asking me to enter a message. Now I enter hello GRIET, which is my message. Now I click on generate key. A random key is being generated. Now I click on encrypt. The my message is converted into encrypted message, which is nothing but the cipher text. This is in alphanumeric form. Now I click on next. I can go to text decryption part. If I click on view encrypt text, I can view back my cipher text. Now I click on get key. The same key is being transferred here since AES uses a common key between the sender and receiver. Now I click on decrypt. My original message is being generated, where a dialog box is generated saying that text decryption is completed. See, I have got my original image, original text. Now, let us look into the text image encryption. Now, I need to choose a image dynamically from the system. So, in order to choose the image, I need to click on Browse. Dynamically, I can search into my system and choose my image. Now, I go into folders of folders and into WT Lab and click on grit.png and I choose my image. The path is being set here. Now, when I click on upload, I can view the image which is being sent to the receiver. Now I click on generate key, a random key is generated, and when I click on encrypt, the image is encrypted here. And a dialog box is shown where image encryption is completed. Now I click on next button. When I click on get key, the same key is being shared here. And when I click on decrypt, the image decryption is completed, and now I can view the original image back. This is text encryption and image encryption. Thank you for watching.